you've been working very intense in terms of HIV, AIDS, etc., COVID-19. You clearly are a pioneer of your industry. Who are you behind all of the, the research, the investigation in terms of your research as a professor? What gives you the drive to get up in the morning and continue pushing forward and finding out the new resolutions?
So I'm the kind of person that wants to solve a problem when I've begun to understand it in a lot of detail. So it all started in terms of HIV back in 1990. So that's 36 years ago, when my wife and I did a study that showed that young girls have very high rates of HIV, much higher than boys. And when we found this, we just said, this is not acceptable, because you're destroying these young girls' lives, not only their own lives, but when they get pregnant, their children are at risk of HIV. They themselves will be at sick and will need care. And, young women are our future. They are the future mothers, the nurses, the teachers, the doctors. So we have to protect them. And so that became my passion. And I've spent the last 36 years just answering that question. One question: how do you slow down HIV in young girls? And all of my research over the years has been focused on answering that one question.
Are you satisfied with your research, Professor? Because obviously, as everyone who does their research, there's always more to improvement. I mean, have we found a solution for that, or are we still working at that?
Well, so when we first started addressing the problem, it became very clear to us that this is going to be a long road. This is not a quick fix. We couldn't just solve the problem just like that. So we started off in 1993. We worked with a US company. We made a product with the nanoxynol 9, and we tested it, and it didn't work. And we then joined the WHO team, a World Health Organization team. We tested another product. It didn't work. And we then went out and we looked and made some other products. We partnered with companies that were making products. And so we spent 18 years doing study after study after study, and every one of them was negative. Every one of them didn't work. Now, you have to say that anyone doing this for 18 years without success would have called it quits at some point. It's a career killer to just have negative results, as an academic. But the problem was still there, and the problem was huge, and the problem needed to be solved, and so we just stuck at it. In fact, it got to the point where when my wife and I, either one of us, went up to the podium to present our latest results, we became known as experts in failure. We were so good at failing, we failed over and over and over. Over 18 years, all we had to show was failure. So it wasn't until 2010 that we then provided the first evidence that showed that antiretrovirals could prevent HIV in young women. And that, for us, was a game changer. That today is widely known as pre-exposure prophylaxis, or PrEP, and is used now in over 100 countries across the world for HIV prevention. So given that we spent all those years failing and to achieve success, for us it's an illustration of the problem that you have to benefit from every failure so that you are on the path to success, that you are learning something to be better the next time you try. If you simply take every failure and don't learn from it, you're not going to get your success. So for us, that has been key. And we've continued to improve on what we originally showed. We keep trying new products. We keep making new things. And we haven't yet found ourselves anything better, but we've partnered with other companies that have shown that we can do much better. So instead of having to take a tablet every day, nowadays, all you need to do is take an injection once every 6 months to protect young girls from getting HIV. And it works really well, too.
How do you deal with failure, Professor? I mean, in your conversation you just said there a second ago, when you said, fail, 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 does that disappoint you at some point where you're not able to find the solution or the results that you need? How do you deal with that?
So I think the first thing about failure is that when we see negative results, I get a bit disappointed and I get a bit dejected, and I ask myself, why did we do this? What did we do wrong here? What happened? And I spend the first few hours moping, and good night's sleep, and the next morning I'm up and I'm ready to take on the next challenge. And I think you have to have that moping, period. It's like your bereavement period. You need to bury the hatchet. You need to bury this problem and start again, because the next, wake up the next morning, you're raring to go now. And for me, that has been really important, that process of failing begins a soul searching about trying to understand why it didn't work. And that lays the foundation for why you can then do better the next time and what will help you on a path to success.
I want to go back. We are going to talk more about HIV and AIDS. We are going to go much more deeper into that, Professor. But I want to know about when you first started your career, and you obviously going to university, studying, etc., and your passion. Yes, at the same time, as you said, it's all about having something to wake up to, which is great now, and it gives you motivation. But at the time, what was it like for you when you were studying, and what sort of aspirations did you have when you were younger that you were hoping to achieve?
So I think that when I was young, I didn't really know what I wanted to do. And I was really taken by one of my teachers. That was my physics teacher, Mr. Sidat, Kasim Sidat. He really made physics live. And he would describe these complex experiments and how they were. And I was particularly enamored by Isaac Newton's research and his contributions to science. So much so that actually I have a Isaac Newton little doll here as a reminder of what a great scientist can do to make the world a better place. And I think he set in motion the process in my mind about the search to answer questions, the curiosity, the need to be curious about the world, to ask questions about the world, and then the need to go about answering them in a very systematic way. And that almost sort of molded my interest in science and my pursuit of science as a career. And it just, because I was excited about it, because I was so enthused about it, I even set up after-school sessions. I used to meet my physics teacher for a half an hour or so 3 times a week after school, just so that I could hear more about what he had to say about all these Millikan oil drop experiments and about Niels Bohr and the way in which electrons went around the protons and so on. But all of that was about instilling three things. The first is the need for curiosity. The second is the need to pursue your interest, to pursue your passion. And then the third was about do it to the best of your ability. If you're going to do something, don't do it half-hearted. Do it so that you do it properly to the best of your ability.
So what you're saying, Professor, is in a perspective is, in order to make success, obsession or healthy obsession is the key. Is that what you're saying?
Yeah, I think in my case, it definitely was an obsession. I couldn't let it go. It had to be done. And so we just keep that. I wouldn't call it obsession as much as I call it, pursuing my passion. I found I was passionate about answering this question. I was enthused about it. I did obsess about it too. And every time when I'm reading a journal article or I'm learning about somebody's new research, I'm always thinking about, so how can I apply it to what I'm trying to deal with? So in a way, it is somewhat obsessive, but always it's about trying to do better. And that pursuit of trying to do better, it doesn't matter what you're doing. I mean, and in my own organization, I try to instill this in everybody. Whether you're the cleaner of the floor, you clean that floor to the best of your ability. You do it better every time because that's what you're pursuing. You want to be really good at what you do, and you want to be recognized for being really good at what you do. Doesn't matter what is it you're doing. And I think that in science, I was just very fortunate that I found something that not only filled that interest in me, but it was also something that I set about doing, which is I wanted to make the world a better place. And this just doesn't come out of the blue. It comes out of my experience as a young black man in apartheid South Africa. That I was always told, you are good for nothing, you are not white, and you are a second-class person. And I wanted to prove that wrong. And so I joined the anti-apartheid movement. I fought against apartheid because I wanted the world to be better. And I knew it could be better. What I was living under was not what I had to live with. I could fight to make it better. And so that pursuing science for the betterment of society, the betterment of humanity, I think gives you that drive and that passion that makes it worthwhile waking up every day.
Do you think, I just heard what you said there, Professor, obviously being a black man from South Africa. Yes, at the same time, we know the world can be very segregated, and let's just be honest and straight. The world can be very racist. Now, do you think, in your opinion, you being segregated and also at the same time discriminated gave you the urge to push forward to become a pioneer in your industry in order for you to prove?
I think so. In every person's life, adversity is a key component of what builds character. So if everything is easy, you just mosey through life. But when you come across difficulties, when you come across obstacles, that's where you are being tested. That's where your grit, your resilience, your power, your abilities are all being put to the test. And the more the challenges are, the more you build your character and the more you build your strength. And to me, my icon was Nelson Mandela. And Mandela built his philosophies around his struggles. And those struggles are not just about, a race, but they were about his identity, who he was as a person. And he translated that into not just himself, but into his entire community of people and the black race more generally. So, you see this, you see that in really powerful people, that they achieve that because they've had to go through hardship, and that hardship built them into what they are, and that's why they don't flinch. They don't, when they come across an obstacle, they don't flinch. They will take it on, deal with the obstacle, find a way around it, over it, under it, doesn't matter. But they will overcome. And that power, I believe, and that's why South Africa has so many, Nobel laureates for Peace Prize and for literature, is because it's an expression of our struggle for freedom, and that is expressed itself in that way. And it's something that's instilled in them, and that came from that hardship.
Do you still have fire, Professor, inside your stomach? I know, obviously, being a leading professor in a top university in South Africa, elsewhere, but do you still have the hunger to? Is there more? Are you content in what you have, or are you still at a point where you need to find more solutions?
So as I've gotten older, two things have happened. The one is I've become a little bit more conservative. I've become conservative means, I've been less risky. When I was younger, I would do research that was high risk because I was willing to fail. And now, as I've gotten older and a bit more jaded, I want to have more success and less failure. And I think that's common, that with age you get slightly less risky. But I still have that fire. And I can give you one very simple example. When the Ebola outbreak was announced in May of this year, I chair the committee for the Africa CDC that advises the Director General on declaring a public health emergency in Africa. And so that's what we recommended. And so what did I do? I flew to the Democratic Republic of Congo, flew to Kinshasa to see what I could do to help in dealing with Ebola. And it's a real problem, because to get to the heart of the Ebola epidemic in the Congo, you can't get to Bunia in Ituri province where the cases are occurring, because there are no flights. They closed the airport to avoid people with Ebola, flying out. And so I eventually, took a UN Mercy flight. The UN humanitarian organization runs these flights. And I get to Bunia, and I go to the hospital, and I'm dealing, the first hospital I go to, Rampara Hospital, there are 18 patients with Ebola in that hospital. 5 of them are medical people, including 2 doctors and 1 anesthetist. And I'm just blown away that, here's a highly infectious disease, and these doctors, are willing to risk their lives, putting on their PPE and going into the wards and helping these patients. It is just stunning. And I felt, well, that's something I should be doing too. As I'm getting a bit older these days, so I'm much more careful. I took my own PPE just to make sure I was going to be well protected. But doing that shows to me that I'm still willing to take up that challenge. I'm still willing to go there and take those risks. But I'm a bit more calculated now in my risks.
Well, that's fair enough, Professor, and it's great to be cautious. Now, for our viewers who are obviously going to say, well, okay, fair enough. Ebola, as you've voluntarily talked about Ebola was a huge outcry. My question is, if people don't understand why there is higher rates than in terms of infectious diseases like Ebola, HIV in certain poorer countries compared to the westernized countries. But at the same time, Professor, people will also question, well, if Ebola, well, clearly Ebola is a very dangerous virus. But at the same time, if it was so dangerous, and it clearly only came to very few people in Europe or in America, etc., how come higher rates are Ebola, how come HIV is far more riskier getting it in poorer countries compared to the westernized countries?
Yeah, I think there are many diseases that show that kind of difference. It works in the opposite direction as well. If you take some diseases like Lyme disease, you see those in the developed world because they interact in the forests with the antelope and the deer and get it. You don't see Lyme disease to the same extent in Africa. However, a disease like Ebola, you see quite often in Africa. Part of the reason is that Ebola is naturally in fruit bats. It occurs naturally in fruit bats. Also occurs in antelope and a few other, like squirrels and so on. But what we are seeing is in a place like the DRC, the Democratic Republic of Congo, this is their 17th outbreak of Ebola. So the doctors there really know how to deal with this problem, and they are very, very good. But to get back to the fundamental issue, that in Ituri province, when I went now to look at the Ebola situation there, what really concerned me was the level of political instability. So the Ituri province is in the middle of a humanitarian disaster. There are thousands of people living in tent towns. They are just internally displaced people because there's a war raging on in that part of the world. And that war is being sponsored by outside agents. They are being sponsored by Rwanda, they're being sponsored by the US and other places that are fighting in that region for the mining ability. So this is a particularly important part of the Congo because there are so many mines there. And there are also individuals who are doing personal mining. In other words, it's not just big mining conglomerates, but also artisanal mining, where individuals are just trying to eke out a living, doing mining for a living. And there's so much of conflict, fighting that's occurring in the midst of that. So that instability means that the healthcare services are struggling, vaccination programs are struggling, disease control programs are struggling. And in the midst of all of that, you now have Ebola. And Ebola loves to have people that are displaced because they are in an unstable situation, they are mingling in different ways, they are in cramped conditions, they don't have access to the same amount of cleanliness facilities and bathrooms and so on like you would have anywhere else in Europe. And it's in those conditions that diseases like Ebola would thrive. Not least because the way in which we can control Ebola is known. It's not rocket science. We know how to control it. We've controlled it many times before. But to control it means that you've got to identify every patient with the disease. You've got to know who's got it. You've got to trace their contacts. You've got to vaccinate them if you have an effective vaccine. And it means that every patient has to be isolated. They have to be kept away from others. How do you do that in a camp? It's not possible. So it's social conditions that are promoting this disease and making it difficult for us to really control Ebola in settings like that. And Ebola is just one example. Many of the other diseases are facing similar conditions that are encouraging and facilitating their spread that you don't have in Europe and other places.
Well, my argument to that, Professor, is, and I totally respect your opinion, but my argument to that, and my debation is very simple. Well, okay, fair enough. These certain countries have fighted along against Ebola, and they know how to keep it secure. But then why us human beings, including, obviously everyone's educated in their own way, but obviously, what my question is, if we know not to, let's say, for instance, eat bats, because we know bats carry Ebola, then why do we do that? And then when we have these outcries and pandemics, we get frustrated and we have to act on it. But at the same time, human beings know the reason behind all of this pandemic.
Yeah, I think the big challenge we have with a disease like Ebola, because there are so many different animals that in which Ebola virus can grow and live. But let's just take bats, for example. In the situation we're dealing with, because urbanization is now encroaching on the caves where bats live, and these fruit bats come into fruit orchards. They go into fruit trees to get the fruit in the day and in the night. So what you've got is a situation where human beings are interacting with these bats, not because they want to, it's because they have no other choice. The bats are now encroaching on them, or that they have to go into the caves where the bats are for their own protection. So you have a situation where homes are being razed, people got nowhere to stay, so they are ending up in caves where bats are, or they are living in fields where the bats are flying every day to come and feed. So they are interacting with the bats not because they want to, but because they had to. And in that situation, it's beyond their control. And it's very hard to prevent these jumps of animal viruses into humans. As we saw with COVID, as we've seen with hantavirus, all of these, they very quickly jump from animals into humans and they can grow in you. And this occurs all the time. So we're living in one planet. Animals, humans, we are one planet. And we have to share the space that we have. And we have to find a way to live with each other in ways that don't harm each other. But humanity is on a perpetual quest to dominate the earth. And they're pushing further and further and further animals out of habitats that they traditionally have used. And bats are in exactly that position. They have a big radius from their cave where they fly to. And as humans are getting closer and encroaching on that radius, they are interacting with bats. So that's going to occur. And it's the same we've seen now with many different conditions. So that's not to blame anybody. That's just to accept that that's part of the way in which the world is going right now.
But doesn't that say, Professor, that the world that we take for, clearly, as you said, Africans, people in Liberia, people in Guinea, Nigeria, they know not to interact with the bats, but at the same time they have to, as you say, because they have no other choice. They don't have to survive. Mm-hmm. Does that not show that the world is very greedy We're so consumed about materialistics and how we can, uh, you know, future our lives in a optimistic and successful manner that we actually don't realize people in Africa or in certain countries, they have to, uh, like you said, they have no choice. Does that
Yeah,
show that human beings are very selfish? We don't actually see the world for what it is.
yeah. I think I've seen, all sides of this equation. I've seen, for example, companies come into Africa and really rape the land, leave it in a destructive way, pollute the rivers. I've seen companies come in and provide jobs, build development, help build infrastructure, clinics, hospitals. So I've seen both sides. I've seen avarice and I've seen generosity. I've seen plunder and I have seen the way in which people and organizations have exercised beneficence. So it takes all kinds. Let me give for me a really powerful example. So when I was there, one of the key organizations that was involved in assisting in the Ebola response is an organization called Alima. Alima is an organization that basically has a whole lot of doctors from all over the world, and they come into this kind of crisis situation and they work hand in hand with Doctors Without Borders or Médecins Sans Frontières. But Alima is the one that uses government funds and they build infrastructure. And when I was there, they were busy building new wards for the Ebola patients, isolation wards, facilities for caring, and the way in which patients can be managed safely by medical personnel. All of that I saw. And that for me was, these doctors from France, from Belgium, from Germany, from the US that were there, they could be sitting in the lap of luxury in fancy hospitals, earning huge amounts of money, treating patients. They've chosen to come here in the middle of this crisis situation where they're putting their lives at risk. That's powerful. And to me, that message that, caring for our fellow humans is what drives the world was a very powerful message. So, yes, I've seen selfishness, but I've seen, real, what's not charity, but the way in which people wanted to make the world better. That was the humanitarian side of what they wanted to do. Made it all worthwhile for me.
Let's talk about HIV. Why haven't we found a cure, Professor? If we're so intelligent and now we have AI, artificial intelligence, and at the same time we have leading professors like yourself around the world who are able to notice, why haven't we found something yet?
All right, so HIV is a cunning virus. I have to tell you that. Very cunning, very cunning. So it does something that few other viruses do. And that is that when HIV causes infection, it takes its genetic material, which is RNA, and it converts it to DNA. It carries its own enzyme to do that, called reverse transcriptase. And the DNA that's made integrates with our own DNA. So it becomes part and parcel of our own DNA in a group of cells called CD4 cells. So in effect, it's like a Trojan horse. It's taken its own material and it's put it inside ours, and it's hiding inside there to come out when it's necessary. And so we can't cure HIV because It's hiding inside our own cells. And it's chosen a cell to hide in that we can't kill. We can't kill a CD4 cell because a CD4 cell is essential for our own bodies to protect ourselves. If you get a chest infection, the cells that orchestrate the immune response to that infection are CD4 cells, the very cells that HIV is sitting inside. So HIV has found a way to hide itself that prevents us from attacking it, what we call the viral reservoir. There's this reservoir of viruses that are integrated into our own cells. Now, we've been trying a whole lot of different ways in which to get at that DNA. And we have a whole range of strategies. One is called shock and kill. And I thought, what a weird name for a strategy. Almost sounded a bit like the Iraqi war, What was it called? Awe and mayhem or whatever it was. Well, the shock and kill is we give a drug to shock the CD4 cells. We sort of wake them up because they often are sleeping cells. We wake them up and we get them to express their DNA. And when it does that, we then know which cells have the HIV in it, and we can give a second drug that will go in and kill those cells. Because we can't kill all our CD4 cells. If we did that, we'd be killing ourselves. So we've tried many of these different strategies. To date, none of them has proven to be successful, principally because even when we kill a whole lot of CD4 cells that have HIV, there still are some resting cells that are very quiet, and they still have HIV, and that HIV comes up again, several years later. So a few people have been cured, about 4 or 5 people now across the world. And these individuals have been cured through a very complicated process that killed off their own CD4 cells, and then they got a marrow transplant of new CD4 cells. And that seems to work. But that's not a practical solution. We can't go around doing bone marrow transplants to cure an illness. Anyway, it's a life's calling to see. It's the ultimate challenge, to find a cure for HIV.
So if someone gets AIDS and it gets developed into AIDS from HIV, because they say AIDS is the last step, does that mean that he's ultimately 100% looking at death?
So AIDS is HIV, the virus, infects a human. That the virus then integrates itself, and the virus and the human sort of find a middle ground where the virus keeps making copies of itself. It's continuing to grow inside your body, killing the cells, and your immune system keeps it in check. So it does that, and does so for several years. But there's a steady exhaustion of your CD4 cells. You wipe your CD4 cells out in this process. And so over the years, and on average it takes about 7 years to do this, that the CD4 cells are so exhausted and there's so few of them left there because the virus has been steadily killing them, that you've got no CD4 cells left to fight off other illnesses. And so diseases that would not normally cause illness now suddenly become killers. Diseases of dogs like toxoplasma, or diseases like unusual forms of tuberculosis, they now become a cause of an illness in these patients, and that's what we call AIDS. AIDS is when these opportunistic infections and opportunistic diseases now take hold of your body because you can't fight them anymore, because your CD4 cells have become so eroded and so depleted that you've got no resources left to fight these illnesses. And that stage is called AIDS. Now, we hardly see AIDS anymore because we have such effective treatments. We use a 3-drug combination that is very, very effective. So mostly today, when we do see patients with AIDS, is because somewhere along the way there was a failure in the system to treat them correctly. And so these are patients who are getting AIDS because they didn't know they had HIV and didn't go on to treatment, or that their treatment is no longer working for them. And that's, it's a very small number nowadays compared to what it was like in the old days, 20, 30 years ago, when we were dealing with patients where almost all would just die when they've reached that stage of AIDS.
Does that disappoint you, though, Professor, that someone who is heavily researched in terms of your research on AIDS and HIV, that you and your team or others haven't able to combat the disease? And that's what obviously we would. So that was my second question I spoke to you when I asked you about failure. Does that disappoint you that you haven't found the solution to that? Or do you think you will find it in the end? Or do you think we will ever get there?
Well, I think one of the miracles of medicine is that, 30 years ago, if you got AIDS, that was a death sentence. It was inevitable. You were going to die. And there was almost nothing we could do about it. Today, no one has to die from HIV. We have a highly effective way of treating these patients. And that's the miracle of medicine. Modern medicine was able to do that, transform a uniformly fatal condition to one that you just live with, as we treat it as a chronic condition. So that's the power of science. The failure of science has also been that, on the one hand, while we've found effective treatments, we haven't found a vaccine, we haven't found a cure, and we still haven't eliminated this disease. And, our goal is to end AIDS as a public health threat by 2030. That's the global high-level declaration from the UN.
Is that because of
For
AI,
us to
though?
reach that, no, it's not AI. I mean, AI, we use AI in HIV for a range of different things, including identifying targets for vaccines and so on. But AI has not given us any major new accomplishments in HIV. Much of what we've seen has come from treatment rather than from AI. I think we would look forward to AI making more contributions in the future, particularly for vaccine design. But it hasn't delivered in that regard yet.
I want to move on to the final subject, COVID-19. As you know, there was a huge pandemic in 2020 that scared millions of people and affected millions of people. What happened there, Professor, in COVID-19? Yes, at the same time, there was a huge epidemic. Was you worried about that, Professor? Because obviously we didn't have the vaccine right at the start, because obviously we weren't prepared for this. What was your thoughts on the whole
So as
COVID-19?
As a virologist and a public health physician, we've always known about the threat that a respiratory virus that we had no immunity to could cause. This was not a particular surprise. Now, SARS-CoV-2, the coronavirus that caused COVID-19, was, the third in a sequence of messages that we got. So the first was in 2002, when a disease broke out in Hong Kong called SARS. And eventually it was shown that SARS actually occurred through civet cats. Well, the civets, they look like cats. They're not quite cats, but they look like cats. And it's our interaction with these cats, with these civets, that led to the spread of SARS. And once it took hold in the human population, it then started spreading because one person coughed, spread to somebody else. But SARS, the first SARS, wasn't very infectious. Its infectiousness was quite low. 10 years later, 2012, we get a second signal. So in 2002, a coronavirus that crossed from one species to another creates this kind of epidemic. In 2012, we get a second message, another coronavirus, this time in camels, spreads in the Middle East, causing MERS, Middle East Respiratory Syndrome, also a coronavirus. And so we already had two signals that a coronavirus could cause mayhem because it spread respiratory. And so in 2019, what we saw was the third signal, that here's a coronavirus, this time from horseshoe bats, that crosses into humans and causes a huge global epidemic, infecting millions of people and killing millions. It was going to come. The writing was already there, the signals were already there that this was coming. And we already know it's going to come again. It's just a question of when and which virus. Is it going to be another coronavirus? Is it going to be influenza? Is it going to be something else? But a respiratory virus that can spread in this way means that every infected person can infect several others. And that process creates a multiplication effect of how fast the virus can spread. We saw that with COVID-19. I hope in our lifetimes, in my lifetimes, I don't see another one like that. But we've seen that. And just remember, it's not new in our lifetimes. Remember, 1918 flu was the worst in human history. We've had bubonic plague, what is called Black Death in Europe. We've seen these historically. And there have been many of these epidemics that have occurred. They're not stopping. We can expect to see more.
Are we prepared, though, Professor? Now, obviously, as you say, we have we have become immune to these pandemics. Do you think, in your opinion, the world, like human beings, because COVID-19 was a really sad, tragic, many people lost their lives. Do you think now that we, us human beings and scientists, are prepared that if anything does happen again, we can act on it quicker?
I really wish I could say we are prepared. Let me say it this way. We are better prepared now than we were in 2019 and 2020. We are better prepared now because we have the ability to make diagnostics quite quickly. We have the ability to make vaccines quite quickly with mRNA technology. So all of those we didn't really have before COVID. So yes, we are better prepared. But are we really prepared as a global community to fight this disease? The answer is no. We're not, because the world came together to create the pandemic treaty. The pandemic treaty is our commitment as a global community to fight a pandemic together. Because when we start fighting amongst ourselves, the virus wins. So we have to stand together against the virus. And in order to do that, we have to have a common understanding about how we're going to fight together. And the pandemic treaty was created under the aegis of the United Nations, was carefully negotiated between all the different countries. And we've got now a pretty watered down pandemic treaty, but at least we have a pandemic treaty. We just don't have it approved yet. Without an approved pandemic treaty, we are in a situation that's going to be difficult if another pandemic arrives. Now, for me, the big obstacle is that the US itself is not just not part of the treaty. It pulled out of the treaty at the beginning. It didn't want to be part of it. But it's also actively working to undermine it. So you've got a problem that we, as a global community, to be ready for the next pandemic, we have to learn to work with each other against the virus. But what we find is that countries like the US are actually working against the rest of us. And that's a problem, because the virus is going to succeed in that kind of situation if we are not united and we don't stand together in dealing with the new pandemic when it comes around. So I worry. I worry that we're not well enough prepared. But I am relieved that we are somewhat better prepared than we were in 2020.
My last question to you, Professor. What advice would you give to young people around the world, obviously as a pioneer like yourself, who's earned the life that you've earned? What would you give to young people that are studying, trying to become a scientist, trying to change the world, trying to become a professor or a lecturer at a top university? What would you tell them?
I'd tell them that, they need to ensure that they pursue whatever they're doing with excellence. They must do the best that they can. But excellence by itself is not enough. They need perseverance. They need to know that they've got to keep trying. They can't turn away at the first obstacle and give up. Giving up shouldn't be an option. When you hit an obstacle, you find a way and you keep coming back and you deal with the obstacle. Because it's that perseverance that leads to us finding solutions when we stay the course. Now, today, we want quick answers. If we don't get a solution quickly, we walk away and we go and do something else. That's not how we will achieve greatness. That's not how we build our society. That's not how we become great scientists. We have to understand that there's no easy road. That if you want quick answers, quick success, quick riches, quick everything, the world is not designed for that, and that kind of pursuit is too shallow. That you take on the challenges of the world, that you do so to the best of your ability, and that you persevere despite the obstacles, is what creates greatness, is what eventually solves problems. And that willingness to persevere is key.
And also my final question, because I think young people will say, okay, fair enough. Is having a high IQ a necessity to become somebody at top of the food chain or in their industry, in your opinion?
No, I have to say, if you've got a high IQ and you have a lot of knowledge and street smarts, you can do pretty well. But many of the people I see achieving great things are not people who necessarily have high IQ. A lot of them know about EQ. They have the emotional intelligence. They are able to work with others to achieve greatness. So to me, it's not simply that you're smart. Being smart helps, no question, and gives you an edge. But it's not just that you're smart, but that